Hello, so in this video, I'm going to talk about electric circuit. In this video, I'm going to talk about the basic idea about the electronic circuit, and also I'm gonna use the problem set so that you can, after this video, you should be able to solve a problem of electric circuit by yourself. So I wanna start with basic idea about electric circuit, and for electric circuit, everything starts from the voltage. So you have to voltage. You have to define all the voltage first. And the important thing is voltage will not be changed. The value of voltage will not be changed until the electric current goes through the resistivity. So resistivity. So everything starts with voltage, but nothing happens without the resistivity. So this is the idea. So first thing you should do is define the voltage, then find the resistivity. That is the flow. And the electric current flow from higher voltage to lower voltage. Higher voltage, high to low. So this is the flow. So you always have to make sure that from the starting point, voltage is higher, and at the end point, the voltage is lower. So this is the idea. And if you study the electric circuit, there are only three kinds of in the electric circuit. One is the parallel or series. And series means basically this is the configuration of resistivity, and you deal with multiple resistivity. But if you see the resistivity in this type of line, you call it series. And another thing is parallel. Parallel means also you're gonna deal with multiple resistivity, but in this case you'll see this type of connection, which what we call parallel. And another thing is combined, which means that you have both series and parallel in one electric circuit. So in this case, you see this is the series, but if you see the whole electronic circuit, and this looks like a parallel, so which is what I call combined electronic circuit. So there are only three one. You have to find which type of series, which type of circuit you have when you solve the problem. The last thing is, and this is a kind of tip, so when resistivity is in series, in something like that, the total resistivity are going to be higher than individual one. So let's say that these the resistivity have each value, and let's say this has the highest one. But if you see this electronic circuit in total, the highest resistivity is always smaller than total one. And if you see the parallel resistivity, the total resistivity is kind of opposite. It's always lower than the smallest one, smallest resistivity. So this is gonna be useful when you after calculation, when you wanna check if your calculation is correct or not. By knowing this idea, you can make sure that your answer is correct or not. So it's pretty simple. The idea is pretty simple, and actually the equations to remember are also simple. So first you wanna know the total resistivity in series, how to calculate it. Which is basically R total. So let's call total resistivity as R total equals to R1 plus R2 plus R3 plus stuff like that. So in here, like, we call R1, R2, R3. So if you see the resistivity in series, the total resistivity can be calculated by just simple addition up. And the total resistivity in parallel. So this is also kind of simple, but the equation is different. Total 1 over total equals to 1 over R plus 1 over R2 plus 1 over R3 plus stuff like that. So of course in this case R1 is this R1, R2, R3. So this is how you wanna calculate. Another thing you have to remember is Ohm's law and Joule's law. And Ohm's law, by using Ohm's law, you can calculate the electric current. And the equation itself is pretty simple. V, which is voltage, equals to I, which is electric current, and R, which is resistivity. Joule's law, by using Joule's law, you can calculate energy that's gonna be consumed at one resistivity, and this can be calculated as P equals to I square R. Again, I is electric current and R is resistivity. And it's important to know that the unit of this energy is going to be joule per second. So this is all you have to know. So it's pretty simple. So let's do the problem set. So this is the problem set. We have two problem set here. So let's do this. Now problem 1, calculate the resistance of 280 ohm and 3.50 kilo ohm, which is 500 ohm, 3100 ohm, and 3.15 kilo ohm, which is 3150 ohm. Resistor connected in series. So in series, the calculation that you wanna use is this calculation. The next one is the calculate the resistance if they are connected in parallel. So for the next problem, the equation that you want to use is this one. So basically you just want to apply this equation using these values. So A equal simply 280 ohm multiply by 3000 ohm plus 3150 ohm. Then the answer is 6930 ohm. It's pretty simple. For B is also pretty simple. Our total equal R1, which is 280, and plus R2, which is 3500, plus the R3 is going to be 3150. And if you calculate this out by using your calculator, you're gonna get the number like 0.00417 or stuff like that. And then our total can be calculated as 1 over 0.00417 equals to 239.5, and the unit is ohm. And it's also important that you want to make sure that this total resistivity is this one. This value is lower than any of this resistance when the resistance is connected in parallel. So this is how you wanna basically know that your calculation is on the right track. Okay, so let's go to the problem 2, and so now you have a combined electronic circuit, and the problem is how much energy does the circuit in the picture dissipate in 1 minute. So this is energy problem, so you want to use Joule's law, which is, let's use different color, which is P equal I square R. And here, and the unit is going to be Joule per second. And here, we know all R, but we don't know I. So, our job is to get I. And so here, how you wanna do is, this is all 180 volt, and from here to here, the current will generate, or the current go through the resistance. So there are two kind of currents. One is current 3, just because this current goes through the resistivity 3, and the top one is, let's call, this is current 1, 2, just because this current goes through resistance 1 and 2. So there are two type of currents exist, and basically by using the Ohm's law, V equal IR, and now you know V and you know R, so you should be calculate I here. And then you want to apply the value of I into this equation so that you can get P. So let's calculate R3 first. R3, well, here R3, what you can make here is the resistivity is 3, since this R3 going through R3 equals to 180. If you compare between this starting point and end point, the difference is 180. So with this, and this is 1 volt, and since this R3 is 90, R3 can be calculated as 180 divided by 90, which is just 2 ampere. And if you plug to this number into this equation, P3 equals to 2 square and 90, which is going to be 360 Joule per second. What you have to obtain is the energy in 1 minute. So in this case, P3, or energy per 1 minute, equals to 360 multiplied by 60, which can be calculated as 21600 Joule. So this is basically energy at 3. Similarly, let's get I12. And in order to get I12, you have to know the total resistivity, and the total resistivity of R12 equal R1 plus R2. Since if you only see this one, this is in series, so you just can use the equation of this one. So you can simply say that this is 45. Then you can calculate I12 equals to 180 divided by 45, which is going to be 4 ampere. So now you see that, like, in this upper place, there are 4 ampere current, like, going through R1 and R2. So let's calculate the P1 and P2 in similar fashion. Now, how you do is basically R square, which is 4 square, multiplied by, in the case of R1, which is 15, so 240. And this is joule per second. So if you want to calculate energy per minute at R1 equals to 240 multiplied by 60, since 1 minute is 60 seconds, this is going to be 14400 joule. Similarly for P2, this is going to be 4 square multiplied by 30 equal 480 joule per second. This is Joule's law. And energy per 1 minute at R2 equal like 480 multiplied by 60. This is equals to 28800 joule. So basically this is the what we did is, like, the B, how much energy at each bulb in the electronic circuit at the picture dissipate in 1 minute. So at R3, like, you're gonna dissipate this amount of energy, and at R1 and R2, you're gonna dissipate this amount of energy respectively. And for A is basically how much energy does the circuit in the picture dissipate. So total energy dissipated in here is, like, just sum up of the energy at 1 plus energy at 2 and energy at 3 equals to 121,600 joule plus 14400 joule plus 28,800 joule. And if you just add it up, you're gonna get 46800 joule. That's how you calculate. So this is the answer for A. I think it's pretty simple, but if you have any question, just please give me a comment in the comment section. I hope it was helpful to you. Bye. See you in the next video.